My name is Goran Blažič. You can find me on social media as Goranče pretty much everywhere, so if you ever need to reach me, just search for Goranče and that will be it. Today I'll be talking about a new feature. Well, it's not that new anymore. It was introduced in iOS 7, background fetch of data. I titled my talk Background Sync, but don't let that confuse you. It did me, so never mind. Just a little bit more info about me. I've been developing software for 2 decades, something like 2 decades for now. That's professionally. Before that, it was a little bit more. So I started on 8-bit computers, and I'm here now. I've been focusing on iOS and OS 10 for the past about 6 years, something like that. Most of that time I've been freelancing. Not all of it, but most of it. I just want to quickly mention, I'm the co-founder and a coach at CocoaHeads. I'm not sure if you heard about that group. It's a group that kind of focuses on trying to balance the number of females in IT in companies as well. One of the major projects we did is an event site for Code Week Europe. Not sure if anyone heard of it, but you can check it out if you want, of course. Just get on with it. Why not? So, like I said before, iOS Background Fetch is an API that was introduced in iOS 7. It pretty much allows an app that goes into background mode. So, I don't know, because we switched to another app, I mean, you pretty much all develop iOS apps, so I guess you know what it means when the app goes into background mode. Like I said, even when the device goes into standby mode. So this is actually an API that is called pretty much whenever iOS wants to. That's the main problem with background fetch. It's very hard to predict when something will happen. iOS is pretty much the one that defines. Actually, it's not really defined. It's something that happens on the fly. It can happen. It really depends on a lot of things. One of the things is how the user actually uses his device. If we use the device, I don't know, 24 hours, pretty much the same, it will behave differently than if, for example, we get up in the morning and turn our device on. iOS will, at least Apple says so, iOS will learn those patterns and kind of try to predict when we want our apps to be synced, which we'll get to, of course. It also depends on the device's connectivity. If we're on Wi-Fi, this will happen much more often than on 3G or, God forbid, Edge. It depends on the battery level as well. From what I've seen, I think the phase of the moon actually does kind of influence what happens. So if it's so unpredictable, why would we use it? The main thing is because when the user opens our app, we can actually make sure that the data that the user will probably want to access will be available when he opens the app. We don't have to refresh, we don't have to do anything like that. Apple also claims that this API actually in the long run reduces battery use. I'm not completely sure about that, but tests seem to show that this does actually hold. So, and in the end, of course, the user experience will be much better, which is important because in the end, happy users is actually better for us, app developers. So, the API is actually quite simple. We pretty much have to do a couple of things. The first thing is we do have to adjust the information we provide about our app in the plist. We have to add a UI background modes array to the info list. If we select it from the drop-down, it's named required background modes. So in that array, we add a fetch key, which again, if we select it, its app downloads content from the network. Or if I just show it, I hope it, oh yeah, you can see it, I guess. This is what it looks like. Of course, the slides will be available if anyone wants to see them later. This has to be added to the info plist. So then we need some code. We need to tell iOS that we have a minimum background fetch interval. That is, it's best done in the app delegate, of course, when we get loaded. So its application did finish launching with options. This function or method call actually just sets the minimum amount of seconds that have to pass between separate invocations of our background fetch code. Now, this is actually just a pointer. Like I said before, the behavior of the API is very unpredictable, so pretty much usually it will kind of take into account that we said, okay, we don't want to be called more often than 30 seconds, but it still may happen. Like I said, it really is unpredictable. The next thing we have to do on our app delegate, we implement one method called application perform fetch with completion handler. This method will be called, our application when in background mode, it will be allowed 30 seconds of runtime to perform whatever it needs to get the data and store it somewhere. Like I said, it's 30 seconds, sorry. In 30 seconds we have to complete everything. If we don't, iOS might actually decide to just kill the app. Just so you know, if someone has some code that's dependent on the app staying in background mode, take care that this can take only 30 seconds. Also, we can actually, as the name of the method implies, there is a completion handler which we have to call. I'll show that later. The completion handler takes one argument where we actually tell iOS what happened. There are 3 states. We can either say, okay, we had a failure, so we didn't do nothing. Then there are 2 success states. One is to tell iOS, okay, we did get our data, but nothing new is available. And the third one is, of course, okay, yes, we got it, and there is new data. So we should return really meaningful results here because it will help iOS decide for future reference pretty much when to call our app. So it will decide on, it might detect a pattern that, I don't know, the data we're retrieving is updating only in the morning, so in the afternoon or at night our app will not be called like this, which is kind of good. Also, this is probably where the battery use drops, I guess. Debugging. An unpredictable message that is sent to our app delegate is, of course, really hard to debug. But in Xcode, we have a very simple debug simulate background fetch command. It's maybe in a weird place. I would kind of expect it to be in the simulator as well, but it isn't. So just so you know, here it is. Also, we'll look at it a little later. I do have some code prepared. We'll go through that. The slides will be online later on, and this code that I'll be showing is on GitHub already, so if someone wants to see it later on, we'll be able to do that. So, if I switch to my Xcode and just say, okay, zoom it. Can you all see this? Is this okay, or? Yeah? Okay. Like I said before, on our app delegate, we have our did finish launching with options. Here we just call set minimum background fetch interval 30 seconds. This, like I said before, tells iOS SDK just to say, okay, we don't need to happen, don't need this to happen more often than every 30 seconds. Again, it might take that into account or not. Now, I've written here a simple data handler class, which is a singleton. It just actually has one interesting method, which is called fetch data. The implementation of fetch data is actually quite simple. It just takes one URL with a string, connects to it, reads whatever it finds there, and writes that to disk after splitting the data that it finds. We'll see exactly how this is done later on as well, but the only return value is a boolean, which is no in case of an error. That's all we have to know for now. Now, of course, for this to work, we need a local server, one I've written in Node.js. It's a very simple thing. It's just an array. For every get request, it will return a simple text plain document with pretty much whatever it finds in this array. Every 30 seconds, a new entry will be added to this array. So if I run this, our server is running. If I connect to it, localhost 8080, it will return the only entry in the array. If I do this 30 seconds later, it will go further, of course. I mean, I will see a date entry like we'll see very soon. One thing to notice here, this is something that never should be done in Node.js code. It's pretty much every request that comes in is delayed by 2.5 seconds. This is just to show that actually something is happening, because otherwise it will be too fast, of course. Oh, a new entry was added. So if I refresh this, again, 2.5 seconds. Oh well, we have 2 lines in the result. That's pretty much it. If I take a look at my main view controller, or let's just run it, pretty much now no background sync has been done, which means that I actually get into my application and I don't have data available. What I have to do, well, we could of course unload, just trigger a sync and stuff like that, but it's still kinda messy. So what we do, we sync, we get it. The way to do this, I mean, one way of doing this is, if anyone noticed before, my data handler, my fetch data actually, is a synchronous call. I hope that everyone here knows that we should never do synchronous calls on main thread. Yes?
Async.
What? Excuse me?
Async?
No, synchronous. On a main thread, you never do that because it blocks the UI. Yeah, or offload it on a background thread. Now, the way I do this here, I have a small component I found online. I don't know, it's a progress HUD written by a guy named Matej. You might have seen that, I don't know. Anyway, sorry, had to. Anyway, the way I do this is actually I just use the progress HUD, show it, animate it, so it pretty much blocks the UI. That's why I used it, not so much for display, but anyway. Pretty much what I do is I call my data handler and to tell it to fetch data, read whatever it finds, and do a reload data on my table view. Now, I hope you did notice that I did a perform selector on main thread. The reason for that is that the progress HUD actually executes this on a background thread. So the UI could work, but in the end I have to call reload data on the main thread on the table view. I'm sure you've all seen patterns like this. You have to do it like that. Now, how do we do this in the background? How can we improve on this? Actually, it's quite simple. Like I said before, if we enter required background modes and say, okay, our app will be downloading, where's my thingy? Yes. Our app will be downloading content from the network. In that case, this method, perform fetch with completion handler, will be called on our app delegate whenever iOS decides that it's the right time to do so. Pretty much simple code, nothing special. We call the data handler. Oh, here, in this case, we of course don't have to worry about the main thread because our app is in background anyway, so we can block whatever we want. It's much easier, of course. What I do is I call fetch data, check its results. If I get a no, like I said before when explaining fetch data, I return a no if an error occurs. If we... Oh, sorry. No, it's okay. If fetch data returns no, this result will be used as the parameter later on. If we do get something back, we actually, I have a very simple case, a simple way of checking if new data is available. I just count the 2 arrays. It's not something you would do in production code. Nothing here is something you would do in production code, but still, it's a good way to show stuff. So what I do, I just store my, the count number of the data I have and check if that is changed. If yes, we have new data. If not, we don't have new data, of course. The last thing we have to do, and like I said before, we have to do this within 30 seconds, because otherwise our app will die. We just call the completion handler with the result we got, and that's it. Now, how can we check this? One way of doing this is, let me first reset this, so we're out of data. Yeah. We know. If I run this and then say, okay, debug and simulator background fetch, the background fetch on the simulator will be performed, and when I run it again, data should be available, which actually happens. So the user doesn't have to refresh, we don't have to trigger refreshes. Actually, data is available when the user starts our app. Now, this is a simple example, of course, but I hope you'll see that this is something that you do want to implement if your app is actually is consuming some data and showing data to the user. One more thing I do have. Well, one more thing. Not going there, not doing that. The user can disable background fetch for individual applications. So if you do write an app that uses this, remember that the user can disable it, so mention it in some documentation or anything like that. That's pretty much it. I tried to keep it short. Any questions? Yeah. Sorry, sure.
Yeah, so consider the fact it's very unreliable. That means you probably have to fetch that data on your app startup anyway, right?
Unreliable?
In a way that it's not going to be called. You don't know when it's going to be called, right?
That's not unreliable.
Okay, let's...
Yeah, you cannot be sure, yes.
The practical use case of a background data using service where you don't know if the data is going to be really fetched in some time period or not.
For example, if you have, I don't know, if you're writing a Twitter client, I mean, on startup you have to check when the last fetch was, of course. I mean, this example was simplified, of course, oversimplified. But you would also, of course, have some date when you did that. So if it's, I don't know, 3 hours old, depends on your use case, of course, you would say, okay, I still have to fetch something. I mean, also, if the app actually starts up immediately after the user installed it, there was no chance for background fetch to actually perform. So you would still have to do that, of course. But in many cases, of course, when your app is running and the user is using it, that background fetch will actually be performed. So yes, of course, not in every case. Not every startup will actually get you in a situation where you do have the data available, but many will. I hope that answers your question. Any, yeah?
Okay, I have 2 questions actually. So the first one is, can you request more time than the 30 seconds that you get?
For the background fetch, no.
So no.
No, but you can do something else, because you can also say, okay, occasionally I will want to start some download, and I want that to, I don't know, because you can combine the different background modes, of course. So yes, you can start a download, but then you have to use an NS URL session and set it up, and in that case you will get other calls on your app delegate, which are not part of this talk, maybe next time, but yes, it's, in that case, you're not really doing background fetch anymore. You have to call the response handler. Not sure what it's called, but the response handler, you have to call it within 30 seconds, even if you start a different background download. So it's not really part of the same API call anymore. So that's why the answer is no, but you can do some other stuff as well.
And the other question is, do you know if the user blocked your app from receiving background fetch?
Excuse me?
If you know if the user disables your app in the preferences?
I don't think so.
So you can't?
I cannot tell you. I mean, I'm 80% sure that no, but I haven't found any information on yes, you can get that information or anything like that. But there might be something. But as far as I know, not.
Right.
Because also you still have to write your application in a way that like it, yeah, of course, because like I said before, you might get in a situation where nothing was fetched before. I mean, so yeah. Anything else? Yeah.
This function perform fetch in background is it also called when the application is in foreground?
No.
No. So
no.
It's disabled. This
not so much disabled, but it doesn't make sense because this is a background mode call.
No, I was asking just as a developer to be careful if this function will be called when the user interface is visible.
It will not be called when you're in foreground, because also if you try to simulate a background fetch, like I did before, of course, yeah, your app will actually go into background mode. So if you notice before, well, I can show it again, of course. Let's say we have this running, and if I do a, no, not on Keynote, but on Xcode, if I do a debug and say simulate background fetch, you will see that the application actually goes into background mode. So the only situation where I'm not completely sure, I haven't been able to test it yet because I haven't been able to, is if the, I'm not completely sure what happens when the method is called in background mode and the user actually presses, while you're still waiting on data and stuff, and the user actually presses on your application and loads it. Well, loads it, brings it into the foreground, of course. I would expect your code will continue to run, so you will have to take care, of course, that you're not overriding stuff. But that's actually a quite easy thing to solve. I mean, it's not, yeah, of course.
It should be easy to test, just to increase the delay in the Node.js server.
Yeah, but I'd have to write code for it to actually test it. I mean, yeah, it is. It's not too hard, but I didn't have time actually. Yeah. Any more questions? Yeah, sure.
So what happens if the app is queued? Otherwise, when it runs out of memory, what happens then?
Excuse me, I didn't hear you.
If the app is queued for some reason, it's using too much memory or whatever reason.
If you're, so what happens, just to be sure I understood the question, what happens if the code in background mode is using up too much memory?
Well, it's in background, so...
Yes? In that case, your application will be killed.
Yeah, and what then?
Nothing. You just, well, the application is unloaded from memory and that's it. Because in background mode, you have to be careful, of course, about your memory use. So, yeah?
What's really the point if the app is not restarted at some point automatically?
Because it's in background mode anyway. any app, the life cycle of an app in iOS, when it's in background mode, you have to be prepared to be killed anytime. So in that case, it doesn't really make sense that you would...
Major downside to this.
I don't think I agree, but yeah, maybe on the, depending on the use case, it might be, yes. But yes, I mean, this is a normal situation where the where iOS, if it runs out of memory, it will start killing apps. So the same thing happens for other background processes as well. If you write I don't know, a music player which runs in background and plays music and starts using way too much memory, you'll be killed. So I don't see this being any different from this particular scenario. So.
Probably iOS does not prioritize this kind of apps, even if it's using only a little bit of memory, and if you have another app that's a huge memory hog.
It does actually. As far as I know, iOS does prioritize in these cases. So it's not as far as I know, it's not looking at, okay, I'm out of memory, I'll kill everything in sight, but it will actually look at, okay, this application is using too much memory. There are actually limits on per app, limits set, so this will, I mean, if you're a little bit careful about your memory use, shouldn't be a problem. I mean, you'll probably use buffers, and if you're using more than 1 megabyte or 2 megabytes of memory, you'll probably flush it to disk or something, well, flash, but never mind. So I don't think that will be something that, with reasonable code, I don't think that'll be a big problem. But still, might happen, yes, of course. But then again, that's part of the normal life cycle of an iOS app, so. Yeah?
If the user kills the app,
yes?
it will be still running in the background, or it will come back to life?
If you actually kill it, well, kill it, so if you remove it from the, yeah?
Swipe it, yeah.
Yeah, if you remove it from the last used list, the application will be removed from memory, yes. From memory, yes.
It will not come back.
Well, until you run it, no. So if you run it again, it will come back, and you'll, depending on the use case, you might have some data flush to flash and have it available, or not. Or maybe decide that it's too old or something like that. Again, this is pretty much something that every iOS app has to expect, that might happen.
So background fetch can actually wake the app if it's hard killed by the user?
No. No, probably not. I would say 95% certain not. It might happen that iOS decides that, also it might change, because that would be something that might actually be useful. From background mode. I don't think from kill mode. Really?
That was changed 2 times. First it was changed in iOS 7, which was hard killed, couldn't actually wake up again in any case. But in that case, they changed that back again, so it actually can.
Then, in that case, it might make sense that the application would be invoked, but not in a full-blown mode, but just for the background fetch, which would make sense anyway, if you ask me. But hey, again, it's not something I would count on, but sure. Any more questions? No? Nothing? That's it? Okay. In that case, thank you very much.